So today's lecture will be focused on queuing models which are available. Basically, we will be focusing on two queuing models only, in which single phase, single channel is there, and in second model we will be discussing about the single phase multi-channel, where you have to get the service in phases. One model we will be discussing where there is one queue and the customer has to get the service from the one system only, that is one phase only. Second model we will be discussing there is a queue, but the customer has to get phase service in the phases. For example, when you go for a car servicing in a car servicing unit, then you enter in a queue, your car is taken up, but car has to be given service by various phases. For example, there is a washing, then after that there is a oil filtering, then there is a wheel balancing, then there is a servicing of the various parts of the car, then after that the finishing of the car is done. So that is getting service in phases. So one model we will be getting when there is one phase only, there is no number of phases. And the second model we will be discussing that is there are number of phases in which the service is provided. So let me share with you these models with some pictures. So the first queuing system or queuing model is single channel, single phase system. As you can see in the picture, that there is a arrival first, the arrow, there is a arrival, and arrival is from the one gate, and then person joins a queue, and there is one queue only. The people join in the queue, and then he go to the service facility, and there is one for service facility only, and he get the service and go out. So arrival, queue, service facility, and served units, they are in a sequence. Number of service unit is one, queue is one, arrival gate is one. So this is single channel, single phase system. So usually in docks, you may have their ships are in the queue, then they join the queue on the dock. There is only one dock, and he join the dock, and after that he go in the ocean. So this is a system where single channel, single phase system is there. So this is one where we will be focusing. Second is single channel multi-phase system, or the service is provided in phases. There is an arrival, one gate is there. On one under one gate you enter into the service station. There is one queue. First customer get the service from the service facility one, then he get the service facility two. So these there are phases. So in this picture two phases are shown. So and after getting the final phase service you go out. So, for example, in McDonald, when you enter into the McDonald self-service system or drive-through service, you enter in the car area. Then there is a waiting for pay. After you pay, then you go to the next counter, that is pick up, and then you go out with the car and food. So this is a single channel multi-phase system. This is the second model which we follow. Third model is multi-channel multi-phase system. So here arrival is from one gate. There is one queue in front of the gate. After that, there are options. Two service stations are there, or three service stations are there, or four service stations are there. You get a service from anyone. So after the queue, you can go to service facility this or service facility this. And once you get the service facility from first phase, then you have to get the service facility from the second phase. Again, there are two counters. You can get the service from this or this. Wherever it is vacancy or empty, you can go and get it. So at a customer use one of the several washes, then one of the several dryers. So laundry system is there, and in that case, this multi-channel, multi-phase system is applicable. Third is multi-channel single phase. So here arrival is there. There is one queue. After that, there are two or three service center. You can join anyone and get the service and go out. For example, in the cinema halls, when you go, there are 3, 4 windows for getting the tickets. There is a queue first. You can join the service facility one or service facility two or go anywhere. Now, after understanding the various methodologies or models of queuing system, there is one thing which is common in all the models. One is arrival process. As yesterday we discussed about it, arrival process will follow a Poisson distribution. That means it is the probability density distribution that determine the customer arrival in the system. How the customer arrive in the system. And yesterday we discussed about it that when a customer arrive in the system, they follow a Poisson distribution. What do you mean by that Poisson distribution? Poisson distribution means the customer who arrive in the 10 minutes before may not follow the customer who will arrive customer after 10 minutes. So suppose if in a 1 hour, 6 customers are arriving, one customer may arrive in the beginning of the hour, customer may arrive in the middle of the hour, and other customer may arrive at the end of the hour. Or all the 6 customers may arrive simultaneously, or all the 6 customers may arrive in the middle of the hour. So the earlier a customer arrive will not be dependent upon the future the customer will arrive. So they will be independent of each other. That is called Poisson distribution. Second, the process. The probability density distribution that determine the customer service time in the system. So if I say same exponential service, that if a customer arrive and it takes 6 minutes to get the customer a service, and in an hour if you service the 10 customers, so that may be served in the beginning of the hour or middle of the hour, or simultaneously they may be served. So on the basis of arrival this will be determined. So the customer who served earlier, whose time will not be depend upon how the customer will be served in the future. So number of number of servers available to the service customer, that will depend upon the methodology or model of the queuing system. What kind of model we follow? You may have multi-channel single phase system, or you may have a single phase multi-channel multi-phase system, or you may have single channel multi-phase system, or you may have single channel single phase system. So all these are dependent upon the models, number of servers available. The first model which we will be discussing is model 1, which is MM1. MM1 means, here first M denotes for the arrival, second M denotes for the servicing, and after that it is written 1. That means single channel single phase system, that customer has to arrive in a single queue, join in single queue, get the service from the single channel and go out. So they follow a Poisson arrival. That means it's not there that if a previous customer has arrived 10 minutes before, the same customer, other customer will arrive at the 10 minutes after. So they will not follow the same pattern. They will be follow a Poisson arrival. That means the arrival of the previous customer is not dependent upon the arrival of the next customer. So they follow a probability distribution which is called Poisson distribution. Similarly, same when you convert it for the service pattern, that is called exponential service, infinite population. Infinite population, we don't know how much customers may come in totality. So when I say model 1, MM1 and FCFS, and after that it is written infinity, it means one channel, one single queue, one service station, and the methodology of serving the customer will be followed first come first serve. Customer who will be coming first and joining the queue, they will be served first. And infinite here means the number of people in the population who are ready to get the service are infinite. So there are certain assumptions of this model also. The first assumption is queue discipline. That means we will be following the pattern of first come first serve while giving the service. Second, there's no balking or reneging. There's no impatience in the queue among the customer. They behave normally. Third, independent arrival. That means constant rate over time. Over time mean, if I say that customers, 5 customers will arrive in a hour, so it means in hour 5 customers will arrive. It doesn't mean that they will arrive after 20 minutes or after 10 minutes or after 30 minutes. So they will be following the Poisson distribution. So arrival will be Poisson distribution. Similarly, service time, if I say that in hour 5 customer will be served, it doesn't mean that they will be served collectively, they will be served after 10 minutes. So in totality, probability distribution is there that they will be served according to some pattern. So average service rate is always greater than average arrival rate. So only then we'll be able to chalk out and run this model. Now, under this system, what will be the performance measures of the queuing system? So in MM1, first come, first serve or FIFO, with the unlimited time, number of customers, we will measure the following things. Number one, we will measure average time each customer spend in the queue. When I say each customer time spent in the queue, it means before getting the service, how much time they wait in the queue. Second, average length of the queue. How many number of customers in the queue, that exclude the person who is getting the service. Third, we will calculate average time each customer spend in the system. When I say average time a customer spend in the system, that means person spend time in the queue plus person spend time in getting the service, that is added. That is called average time each customer spend in the system. Then we will find out average number of customers in the system. Average number of customers in the system means average number of person in the queue plus the person who is getting the service. Then what is the probability that the service facility will be idle? This is called intensity. That means if there is zero customer in the system, that probability we have to file. At least one customer in the system, that probability you have to file. Next is utilization factor. Utilization means the probability that, what is the probability that the system is busy. One, we will calculate what is the probability that the system is idle. Second, we will calculate the probability the system is busy, that is called the utilization factor for the system. And finally, you will be filing, we have to find out how many specific numbers of customers in the system, probability of specific number of customers in the system. What is the probability that there are 5 customers in the system? What is the probability that there are 10 customers in the system? What is the probability that there are n customers in the system? So for calculating all these, we will be using the following formulas. Here, 2 notations have been used. You can note down. First notation which I have used, that is the reverse y, which is the mean arrival, which represents the mean arrival rate, which is denoted with lambda. So this sign, which is the reverse y, it is called lambda. So the second notation which is used here is like u, that is mu, MUE. First notation is lambda, LAMDA. Second notation is mu. Now, as far as lambda is concerned, you can note down lambda here is mean arrival rate. Lambda here is mean arrival rate. You can note down. So this notation, that is the reverse y, which is known as lambda, is denoted with mean arrival rate. And the second notation which is used here is mu. Mu is a mean service rate. Lambda is mean arrival rate and mu is a mean service rate. First, we have to find out average number of person in the system. Average number of person in the system will be found out with this formula, lambda over mu minus lambda. That means mean arrival rate divided by mean service rate minus mean arrival rate. So mean arrival rate or mean service rate, you may calculate per day, you may calculate per hour, or you may calculate per month as the time given in the question. Now, second is, what is the formula for average time a person spend in the system? First, we have calculated average number of customers in the system, which is denoted with EN. Here is expected, and here is in the number of person in the system. So expected number of person in the system is lambda over mu minus lambda. Average time a person spend in the system, that is EW. W here is waiting time in the system. So the formula is 1 over mu minus lambda. So this formula we will be remembering. Third, average number of person in the queue. First we calculated the average number of person in the system. Now we will calculate the average number of person in the queue. The simple formula is here E L. L here represent the line. So that is lambda square over mu into mu minus lambda. So this will be the formula for finding out how many persons are in there in the queue or in the waiting line. Next, now we'll be finding out how much a time spent a person in the queue. That is average waiting time. So W here is a waiting, Q is a Q, small q is a Q. So lambda over mu into mu minus lambda. Fifth thing which we have to calculate, there is the utilization factor or row intensity. So here this symbol which is used here is a rho, RHO, rho. And the formula for calculating the probability that the system is busy or the utilization factor is lambda over mean. That means mean arrival rate divided by mean service rate. Now this row will explain you how much the system is busy, how much probability is there that the system is busy. But now if you have to calculate what is the probability that the system is zero, that means zero customer in the system. P here is a probability, zero here means zero customer in the system, that is 1 minus rho. So 1 minus utilization factor will be the percentage a system will remain idle. So by using these formulas, we can get these all information which I have listed there. That is average time a customer spend in the queue in the system, average number of person in the queue or in the system, how much probability is there the service time is idle, how much probability is there the system is busy. So or we have to find out the probable number of the customer in the system. So these 6 formulas we will be using. So notations which I have used, I again explain you. En here is expected number of customers in the system. El here is mean expected persons waiting in the queue. Et here expected time a customer spend in the system. EW expected time a customer spend in the queue. So n, small n is here is the number of customers in the system, and Pn is the probability that they are n customers in the system. So if you want to find out the n customers in the system, rho raised to the power n, you can denote and find out the n customers in the system. Let us take an example. For example, an electricity distribution company has one cashier at a bill discount counter. So it means there is one cashier. It means service will be provided by the one channel only. 18 customers arrive at an average 10 minutes. So her 10 ਮਿੰਟ ਦੇ ਵਿੱਚ 18 ਕਸਟਮਰ ਆਉਂਦੇ ਆ and cashier serve 20 customers in 10 minutes. So here you have to find out two things. Number one is mean arrival rate. So because the arrival rate is given 10 minutes, so we will get the information both in 10 minutes. So mean arrival rate, that is lambda, will be 18 over 10. That means after every 10 minutes 18 customers are arriving, you can calculate per minute, that is 1.8 customers in a minute. Similarly, 20 customers are served in 10 minutes. So it means 2 customers are served in 1 minute. So 20 divided by 10. So this we have calculated. Now, these two were the things which we have to calculate. Other things are given in the question and you have to remember the formula. So expected number of customer in the system, if you have to find out lambda over mu minus lambda. So here 1.28 and 2, these figures you will put in and you will get the service. You will get the result. Similarly, other formulas in the queue, if you want to find out lambda square over mu into mu minus lambda, again what you have to do, you have to remember the formulas and simply calculate two things. One, you have to calculate the mean arrival rate. Second, you have to calculate the mean service rate, and both should be calculated in the same fashion. If they are in calculated per minute or per hour or after 10 minutes, same should be there in both, that is mean arrival rate and mean service rate. So we'll be putting these information in the formulas and getting all these results. So you will be asked like this question, and mostly this question is solved within 5 or 7 minutes in the question paper, and you will be surely getting one question on the queuing theory. So second model is Erlangian service time distribution model with K phases. Here there is one queue, but the service is provided in the phases. So it was stated that the service of the customer is earlier model, service of the customer was completed in one step only. But sometimes there are situations where customer has to pass through various phases to get the service, as I have given the example of the car servicing. A car entering the for the repair garage has to pass first washing unit, second to pass servicing unit, and then to pass checking a unit to get the complete service. So these three units in terminology of Erlong model. Erlong was a AK Erlong was an engineer who devise this model to and devise these formulas to get the various kind of informations for this. So if you can have the following type of picture for that. For example, there is a waiting unit in front of the gate, then person enter in the queue, he has to get the service from the first phase, then second phase, third phase, and then departure is there. So these phases, number of phases are denoted by K, capital K. So if there are two phases, K will be equal to 2. If there are three phases, K will be equal to 3, or so on. If n phases, K will be equal to n. So this is the model which Erlong has developed. So these are the formulas which we'll be using for that. So model has two assumptions that same, the distribution of the arrival is Poisson and the distribution of the servicing is exponential. So important results here, what we have done, average number of customer in the system, the formula will be like this: k plus 1 divided by k 2k into lambda square over mu into mu minus lambda plus rho, that is lambda over mu. Similarly, other formula for finding out the average number of customers in the queue, k plus 1 divided by 2k into lambda square over mu into mu minus lambda. Similarly, third, average waiting time a customer spend in the queue, that is k plus 1 over 2k into lambda over mu into mu minus lambda. Similarly, average waiting time of a customer in the system, k plus 1 plus 2k divided by 2k into lambda over mu into mu minus lambda plus 1 over mu. So here k denotes the number of phases. Other notations we have used are the same. Let's take an example of this question. A hospital clinic has a doctor examining every patient brought in for general checkup. The doctor averages 4 minutes on each phase to check up, although the distribution of time on each phase is approximately exponential. If a patient goes through 4 phases in checkup, and if the arrival of the patient to the doctor cleaning are approximately Poisson at the average rate of 3 per hour, then compute the following. So 4 minutes are taken for each phase. So mean servicing rate is there. And average rate of 3 per hour is given for the arrival of the customer. So first we have to convert all this in minutes. So first of all, here the k is equal to 4. Mean service rate, that means it takes 4 minutes, and 4 phases are there. It means total 16 minutes are there to serve one customer. Then mean arrival rate. So mean arrival rate you have to calculate in minutes now, because you have calculated the mean service rate in 16 minutes in minutes. So mean arrival rate will also be that we are serving the 3 customer per 3 customer per hour. So it means you are taking 20 minutes for the arrival of the customer. So it means mean arrival rate will be 20 minutes. So hence mu is equal to, because you have to, these are the minutes, you have to convert it in the numbers. So 1 by 16 ho jayega. So it means in 1 minute mean arrival rate is 1 by 16. Lambda arrival rate will be 1 by 20. So here we have calculated the mu and lambda. Now other information we have to put it in the formulas only and get the information as required. And accordingly we can take the decision that how we are affected, whether we are affected by the number of person in the queue or in the system or in the time spent in the system or time spent in the queue. So it is nothing. You have to just remember the formulas, calculate the values of the lambda and mu, and in your syllabus only elementary queuing theory is there. That means only 2 models we will be discussing. One is Erlong model where the service is provided in phases, and second is model 1, that is MM1, that is FCFS, and where infinite population is there. So only 2 models you will be focusing. Very small question will be there, and that question will be solved in 5 to 7 minutes. You must focus on ਘੱਟੋ ਘੱਟ ਜਿਹੜੀ ਤੁਹਾਡੀ ਬੁੱਕ ਦੇ ਪਹਿਲੇ ਮਾਡਲ ਦੇ 5-6 ਕੁਐਸਚਨ ਸੋਲਵ ਕਰ ਲਓ, ਤੇ 2 क्वेश्चन ਜਿਹੜੇ ਆ ਲੌਂਗ ਮਾਡਲ ਦੇ ਸੋਲਵ ਕਰ ਲਿਓ ਜੇ, that's final, you will be able to get 1 question out of that. So that is end of queuing theory, queuing model. So now you can on your videos. If you have any question, you are most welcome.
लाइक सर हमने ये वाला चैप्टर फर्स्ट टाइम किया है ना, पहले था नहीं, तो आप इसके नोट्स शेयर कर देना, ये प्रेजेंटेशन।
हाँ कर डेफिनेटली डेफिनेटली मैं पूरा चैप्टर ही ਤੁਹਾਨੂੰ ਭੇਜ ਦੇਣਾ if you have not done earlier।
Yes sir,
पूरा
Thank you,
चैप्टर
sir.
हो कोई गल। और